In this video, I want to talk you through a Mann Whitney U test. So what it is, when you would use it, and how to perform it in R. And this will be very familiar to you because it's basically the same as a two-sample t-test, except this is the non-parametric version. And it tests the statistical difference between two population medians rather than means. So remember, medians are tested when you use your non-parametric tests. Remember to check your assumptions again. So if these can't be fulfilled, if there's not a normal distribution, if the standard deviations are out, then we tend to turn towards this non-parametric Mann Whitney U test, which tests these medians. So again, it's testing whether there's a difference in the medians between two populations. It's a bit more robust to outliers or skewed data. And you might be using this similar to that example we looked through with the two-sample t-test, when we're checking whether the median blood cholesterol value is different between men and women. So our two populations, one being the men and two being the women. So how would you do this in R? Well, actually, it's pretty similar to how we do the two-sample test and how you would check these assumptions. So first of all, I'm in my working directory and I'm going to read in this data set, and I'm going to check the names. If we have just a quick look at what that looks like, we've got the sex and we've got cholesterol level. So we've got all the females and then we've got all the males. And again, what we want to do is check for those assumptions. So are both of those populations approximately normally distributed? So I'm just using the subset function. So I've just called it cholesterol female and then NP for non-parametric. And I'm subsetting that data set that I've just read in for females only. So let's have a quick look and see what it looks like. So we run that in. If we run it in for the males, we're subsetting. And now let's have a quick look and see what it looks like using that histogram function. So you can see here there's a big gap here. You wouldn't say that that's approximating a bell curve. And you may want to try log transforming it. So you can use a two-sample t-test. But in this case, we're going to check the males and then proceed with a Mann Whitney U test. So let's check what the males look like. So again, it doesn't look like it's approximating that normal curve, that normal distribution. So this would be appropriate to test using a Mann Whitney U. And the code for doing this is very similar to what we did for a two-sample t-test. So we've got that cholesterol level that we're looking at as a factor of sex, so splitting it up into those two populations. We've told R what data we're looking at, except rather than using the t.test function, we're using the wilcox.test function here. Otherwise, the code is very ssimilar to what you used for the two-sample t-test. So I'm going to click Run, and you can see that it's given me that Mann Whitney U, and it's given me the Wilcoxon rank sum test with continuity correction. It's told me that it's looked at cholesterol level by sex, so males and females. And instead of getting a t-test statistic, we've got a w-test statistic here. And we've also got a p-value. So again, this is given in standard form. Remember to put that as p is less than 0.001. And that's how you would do a Mann Whitney U test in R.